I think you know now what exception is, how to handle exception in a program, and what is the job of these three keywords in the program of exception handling. This is the program which we discussed. Compare this with this program. Here we handled that error manually. If y is equal to 0, display error. You may say, sir, you are doing same thing here. If y is equal to 0, exception object is thrown, so control will enter into catch block because this code is written in try block, and in catch block you have written that same thing, error. So actually you are making this program complicated. This one is easy, isn't it? This question you may get. In next program, I will try to explain why this standard method of exception handling is preferred over this manual method. In this program, again I am doing job of division only, but that in a function. Divide is the function. I am going to write that function definition here at the top of main function. In every program of this chapter, I am writing this statement as the last statement in main function, just to confirm that the program executed successfully. Complete code executed without any error. Yes, so let us write divide function. It accepts two arguments and returns the result. Yes. In this program, I am not asking to user values of x and y. Instead, I am assigning those values in the program. What will be the output? Yes, output will be 5. The answer is 5. The end. Now tell me what will happen. Of course, sir, program will terminate. Runtime error. Exception will occur. Yes. What to do here? We know keyword throw that should be used here. We know try catch block is required here. But how to do that? Code of division is written in one function. That function is called in other function. We know the keywords throw, try, catch, but how to use those? Or okay, you may say, sir, I don't want to use try and catch blocks. I don't want to use keyword throw. I want to go for this manual method. If y is equal to 0, display error. That means here, if y is equal to 0, display error. But this is not the correct way, because you have to just return the result to the calling function. Don't display the error. So you may say, sir, I will return some odd value, say -1. That means divide function returns -1 if divide by 0 error occurs. This is how you will explain working of your divide function. This is manual way of handling error. Then code in this divide function needs to be changed. If z is equal to -1, then display error, right? Actually, a function can return only one value. So what C++ says, you return the value of result to calling function. You don't return the error value to the calling function. If error occurs, do not return any odd value. You just throw some exception. I am repeating it. If some error occurs in a function, that message give through exception and not through return value. Where to use now try catch block? Suppose this function is some library function. directly available to us, and in its documentation it is written that this function throws an exception of integer type if divide by 0 error occurs. Then while using it, we know that this function throws some exception. We will write it in try block. This is corresponding catch block. Let us run it. First time denominator is not 0. Answer should be 5 and the end should be the last line on the screen. Yes. Now denominator is 0. We want the end. Yes. Error divide by 0. I hope you got it. So exceptions are useful when you are defining a function and you want to return message of some error. That time instead of returning some odd value, better you throw some exception. That will be handled by the calling function. Here you may ask, sir, here throw 55 is written and there is no try catch block, so program should terminate. Actually, when this divide is getting executed, that time content of stack will be, yes, there will be main function written there. You know, stack is used to handle function calls. And what is the rule? If some exception occurs and if it is not caught in a function, then CPU looks into the stack. It goes to the calling function and checks there. Like this, it is called stack unwinding process. It searches in all the functions through that stack, and somewhere if try catch block occurs, then that exception is handled. Of course, that exception object should be caught in that catch block.